Suppose you have a particular wavelength. For example, suppose your wavelength is 486.1 nanometers, and you want to get a frequency from that. The relationship between frequency and wavelength is wavelength times frequency equals the speed of light. So if you want the frequency, you're going to have to solve that equation for frequency. Solving an equation means getting your unknown all by itself on one side. So I have to get the frequency all by itself on one side of this equation. So what I'm going to have to do is divide both sides of the equation by the wavelength. So my frequency is going to be equal to the speed of light divided by the wavelength. Okay, let's put in the numbers. The speed of light is a constant that I can just look up. The wavelength is going to have to be in meters because the speed is in meters. You've got to have the units consistent. So I can't just put 486.1 nanometers down here and expect it to work. I have to put the wavelength in meters. Now that's very easy to do because you know that nano means times 10 to the minus 9. So that's the setup for it. So your frequency is going to be, if we key this in, 2.9979 to the 8th times 10 to the 8th divided by 486.1 EE, that means times 10 to the minus 9, and I get 6.167249537 times 10 to the 14, and my units are going to be 1 over seconds. Alright, I didn't round this off because it's an intermediate result. I'm going to use it now to calculate the photon energy. So if I want a photon energy, the photon energy is Planck's constant times the frequency. Planck's constant is a constant that I can look up. It's 6.626 times 10 to the minus 34 joule seconds. And I'm going to multiply it times the frequency that I just wrote down. And when I do that, it's going to be it's going to be 6.626 times 10 to the minus 34 times, well, let me try that one more time, 6.626 times 10 to the minus 34 times 6.167249537 EE 14, and I end up with 4.086419543 times 10 to the minus 19, and my units are going to be joules because joules times seconds times 1 over seconds is going to give me joules. How many significant digits? I knew the wavelength to 4 digits, and I wrote this out to more than that, so this is going to be rounded off to 4 digits. So my final answer here is going to be 4.086 times 10 to the minus 19 joules for my photon energy.